In this video, we're going to talk about Stevens' scales of measurement and properties of measurement. Stevens was a psychologist who, around the 30s and 40s, put forward a way to conceptualize scales of measurement in an effort to, in part, to make psychology more scientific, because a science is, in a way, only as strong as its measurement methods. So this isn't like incredibly important for data analysis, but it is another way to think about variables. And knowing your variables is an important first step in being able to analyze data. So the scales of measurement that Stevens put forward are based on several properties of measurement. One is the identity property of measurement, which basically states that levels on the scale are mutually exclusive and each level represents a distinct level of the variable that's being mentioned. So most scales will have this. If it doesn't, it can be really problematic to analyze. So if you had a multiple choice question where multiple options were possibly correct, that would kind of violate this identity property, and it would be difficult to use it in a statistical analysis. Not impossible, but difficult. Magnitude property basically states that higher scores indicate more of the thing that's being measured. So like a greater frequency, a greater quantity of something, so that's the magnitude property of measurement. Equal intervals occurs when the difference between equal distances on the scale have the same meaning. So the difference between being 5 and 6 years old is the same as the difference between being 7 and 8 years old. So when a scale has the property of equal intervals, equal distances on the measure that we're talking about are basically equal in terms of what's being measured, or the underlying property that's being measured. And the property of absolute zero means that it has a meaningful absolute 0 point. So actually, by meaningful 0 point, it doesn't just mean that the 0 point has meaning. It means that the 0 point represents the complete absence of the property that's being measured. So 0 truly means the complete absence of whatever is being measured. So these properties combine to define Stevens measurement scales, and you can use a mnemonic device to try to remember these. Noir, N-O-I-R, which in French I believe means black. So here we have nominal. So a nominal scale, or a nominal variable, is typically a categorical variable that has no magnitude property, no equal intervals, and no absolute zero. It's basically just a name or a label for the variable, right? So we'll go over some examples in a minute, but just for now, know that nominal variables are just simply labels, and they don't quantify anything. Ordinal variables, on the other hand, tend to be either rank-ordered categories or ranks in general. So an ordinal variable will have roughly some property of magnitude. So if we're talking about a race, the first person that finishes the race will finish it faster than the second person and the third person and so on, but it doesn't mean that they're equal distances or equal times apart, right? So ordinal is basically a rank-ordered variable. Interval is a variable that is basically has the same difference across the scale, across a similar difference on the scale. So the difference between a 1 and a 2 on the scale has the same meaning or the same difference as between a 2 and a 3 on the scale. But an interval variable would not have a meaningful absolute 0 point. So the 0, so for instance, a 0 in Fahrenheit is not the complete absence of what's being measured, so it would be Fahrenheit would be considered an interval variable and not a ratio variable. A ratio variable basically has the property of magnitude, equal intervals, has an absolute 0 point, And the 0 truly represents, or at least approximates very closely, the complete absence of the thing that is being measured. So many behavioral measures might be a ratio variable. So for instance, the number of times you sneeze today is a ratio variable. So 0 on that scale would mean the complete absence of sneezes. You sneeze 0 times. Many psychological scales of the self-report variety kind of don't fit nicely into this categorical scheme of labeling variables. Many researchers will treat self-report psychological scales as interval. And some people put forward the term approximately interval for many psychological scales. So something like a self-esteem scale. If there's a 0 point on the scale, it doesn't truly mean that you have the complete absence of self-esteem. It probably means you have very low self-esteem, but it does not mean that you have the complete absence of the property that's being measured. So for ratio, 0 must truly mean the complete absence of the thing that's being measured. So let's quickly take a look at some examples. So nominal, something like race or ethnicity, gender or sex. Jersey number, so the number on a jersey, it probably doesn't represent more of something. It's just kind of like a label, even though it is a number, it's a label, so that could be considered nominal. College major, basically anything that's just a label but is a variable could be considered a nominal scale or nominal variable. Ordinal, as we mentioned, are rank ordered categories, so examples might be finishing position in a race or class rank. So the key here is that we do have some property of magnitude, but the differences on the scale, let's say between first and second and third and fourth, are not necessarily equidistant in terms of the property that's being measured. So that would be an ordinal variable. An interval variable now has the property where equal distances on the scale have the same difference in magnitude. So something like temperature in Fahrenheit. And as I mentioned, many psychological scales might be assumed to be interval when in reality they might be ordinal at best, but some people have taken up the term approximately interval for many self-report psychological scales. And ratio basically has all the properties: magnitude, equal intervals, absolute 0 point. The key distinction here is that 0 means absolutely none of the property that's being measured, or 0 means absolute 0. One way to kind of remember this is that, well, since ratio ends with an O, you can pretend that's a 0, and that can hopefully jog your memory if you forget what a ratio variable is. It's one that has absolute 0. So many measures of frequency of behavior, measures of things like length, weight. You may remember back to high school days, temperature in Kelvin is assumed to have an absolute 0 point. So that's one way to understand these scales of measurement. Now again, these aren't terribly important for being able to do statistics, but it is nice to have information and to be able to identify the variables that you're working with, because that can be useful in determining which sort of analysis you might use. All right, thank you, and hope you enjoyed that.